Okay, so question number 8 says to draw a Lewis structure for nitric acid, HNO3, and they told us that the nitrogen atom is in the center and the hydrogen atom is bonded to an oxygen atom. Okay, so that's helpful. And we first need to find out the total valence electrons for nitric acid. So hydrogen contains 1 valence electron. Nitrogen has 5. Oxygen has 6. And we have 3 oxygen atoms, so we multiply this by 3. And when we add the values all up, we end up getting 24 valence electrons. So the question already gave us a helpful hint that the nitrogen atom is in the center. And let's draw 3 single bonds to all of the oxygens, with one of the oxygens having the bond to the hydrogen. So now if we look at the nitrogen, we need to draw a double bond to one of the oxygens. And then we will fill in all of the lone pairs. Okay, so now we have the final structure for nitric acid, but we also need to include any charges that this Lewis structure might have. So to calculate formal charge, it's going to be the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So let's calculate the formal charge of the single bonded oxygen. There are 6 valence electrons. The number of non-bonding electrons, so the lone pairs, is equal to 6. And there's a single bond containing 2 bonding electrons. So we have 2 divided by 2, making that oxygen have a -1 formal charge. So we can just add a negative beside it. So now let's calculate the formal charge of the double bonded oxygen. It also has 6 valence electrons. This time there are 4 non-bonding electrons and also 4 bonding electrons since there's a double bond. And it has a formal charge of 0. So now if we were to calculate the oxygen with the hydrogen, so I just put OH. There's also 6 valence electrons, 4 non-bonding electrons, and the 2 bonds to it. So like the double bonded oxygen, it also has a formal charge of 0. And if I were to do the same thing for the hydrogen, which has 1 valence electron, no non-bonding electrons, and 2/2 bonded electrons, it's also 0. And finally, let's calculate the formal charge of nitrogen. Nitrogen has 5 valence electrons. There are 0 lone pairs in this structure on nitrogen. And there are 4 bonds to the nitrogen, so that means we have 8 bonding electrons divided by 2. So 5 minus 0 minus 4 is +1. So we know that the nitrogen will contain the positive charge. And typically we want the more electronegative atom to contain the negative charge. So in this case it's the oxygen. And the nitrogen is able to neutralize that charge as well to get our neutral compound. So the junior tutor said first we need to find the total number of valence electrons, which they got was 24. And then they drew the Lewis structure of the compound. So it doesn't look like the picture showed up. 2 single bond and 1 double bond to nitrogen. Double bond oxygen to nitrogen, or 1 single bond hydrogen is attached to an oxygen. So they just kind of try to describe it. So the steps are correct. The image, however, is not shown. So I'm just going to say the solution is incorrect so that we can look at this.